So in this video we are going to draw 10 of the most important Lewis structures that every chemistry student should know. Before we start drawing, we need to understand two key concepts. First, how to identify the central atom in a molecule. In most cases, the central atom is the least electronegative atom, excluding hydrogen. Second, we need to determine the number of valence electrons for each atom. A quick way to do this is by looking at the atoms group number in the periodic table. I explained for you. Once we know the central atom and the total number of valence electrons, we can start drawing Lewis structures step by step and determine lone pairs, bonds, and molecular shapes. So, before drawing Lewis structure, we need to identify the central atom. I'll explain for you. The central atom is three main rules. I will write for you 3 rules of central atoms. Number 1. Hydrogen is never the central atom. For what? Because it can form only one bond. Number 2. The central atom is usually the least electronegative atom in the molecule. I will explain for you the electronegative is what is it. Number 3, the atom is, the atom that can form the most bonds is often the central atom. Like what? Like carbon. So, for example, in carbon dioxide, CO₂, what is the central atom? It's C. For what? For it can form the most bonds, and it's less electronegative than oxygen. For example, in ammonia, NH3, nitrogen is central atom. For what? Because hydrogen can never be the central atom. Nitrogen. So, now let's talk about the electronegativity. What is the Electronegativity. So, electronegativity is an atom's ability to attract electrons in a chemical bond. As we move from left to right across the period in the periodic table, electronegativity increases. For example, period 4, potassium, calcium, scandium, and etc. Electronegativity increase. As we move down a group, electronegativity decreases. For example, group 17, fluorine, chlorine, bromine, iodine, and etc. Electronegativity decreases. So fluorine is the most electronegativity. So now we need to determine the number of valence electrons. The easiest way is to look at the elements group number in the periodic table. For the main group elements like group 1 have 1 electron in valence, and group 2 2 electrons. Lithium, sodium, potassium, rubidium, and etc. Group 2, beryllium, magnesium, calcium, strontium, and all of them have 2 electrons, and group 1 has 1 electron. Group 13 have 3 electrons, like what? Bore, aluminum, gallium, and etc. Group 14 have 4 electrons, carbon, silicium, germanium, and etc. Group 15, 5 electrons, like what? Nitrogen, phosphor, ASN, etc. Group 16 have 6 electrons. Like what? Oxygen, sulfur, selenium, and etc. Group 17, halogen, have 7 electrons. Like fluorinium, chlorine, bromine, iodine, and etc. Now we can draw the Lewis structure of these compounds. First of all, carbon dioxide or CO₂. What is the central atom, you say? Think. So, C. Is it true? Yes. C is the central atom. And we have two oxygen. Oxygen is belong to group 16. So oxygen have 6 valence electrons and another oxygen. Carbon belongs to group 14, so it have 4 valence electron. So carbon make 2 double bond, 1 electron, and 1 electron make 1 double bond and 1 electron and 1 electron, another double bond. So finally the Lewis structure of carbon dioxide, C, and so water or H2O. What is the central atom? Hydrogen, so it can't. So oxygen is the central atom. Oxygen have 6 valence electron. Hydrogen is belong to group 1, so 1 electron, valence electron. So oxygen is the final form. It's a V shape. So H2O is a polar molecule. Ammonia or NH3. What is the central atom? It's nitrogen. Nitrogen belongs to group 15. 15 have 5 valence electron plus 3 hydrogen. Its final form is like that. So methane, CH4. So the central atom is C, belongs to group 14, have 4 valence electrons and 4H4. The final form is C, 2H, 3H and 4H. Sulfur dioxide. It's important. The central atom is sulfur. For what? It have less electronegativity than oxygen. It belongs to group 16, so it have 6 valence electrons plus 2 oxygen. It's exceptional. For what? So 1 electron make one bond with one, will make one double bond with one electron, and so one oxygen make this form. Make an empty place for these double electron for sulfur. The final form is it's so nitrogen dioxide. The central atom is nitrogen plus 2 oxygen. It's an exceptional compound. Please focus on it. So nitrogen make one double bond with one oxygen, so it's normal. So it remains one double electron and one lone electron. So, and this oxygen. So oxygen transfer the electron and double electron, make double electron. Yes, and final form is nitrogen, oxygen, 1 oxygen and 1 lone electron. It's exceptional. These nitrogen haven't octet form. It means these nitrogen haven't octet form. 8 electrons. This compound is exceptional. It's important. Memorize that. So now we can draw the Lewis structure of ions. Nitrate ion, NO3 minus 1. So first of all, the central atomic is nitrogen. Yes. So minus 1, it means the molecule take 1 electron more. So plus 1 electron makes nitrogen like this form. So now we can draw the Lewis structure of NO3 minus 1 plus 3 electron. So double bond with 1 oxygen as normal and 1 electron. Transfer these make this form of oxygen, one empty place, and another one, make this form, make empty place too. So one this oxygen and another oxygen, and finally we make a bracket and put -1 here for ions. Carbonate 2, CO₂. The central atom is carbon. So carbon have 4 valence electrons. So 2 minus means CO3 take 2 electrons more. So 1 electron and 1 electron. Now the final form of Lewis structure of CO₂², exactly like NO3 1. You see 1 double bond with 1 oxygen and 1 and 2, and bracket 2-. So ammonium NH4 plus 1. So the central atom is nitrogen, have 5 valence electrons. Positive means NH4 lost a electron, so 1 electron goes to trash, and nitrogen make this form. So now is easily to draw 1H, 2H, 3H, and 4H. Finally, a bracket with positive. Sulfate 2-, SO4 2-. So S have 6 valence electrons. 2- means SO4 take 2 electrons. So it means S make this structure 8 valence electrons. So make this form S 1 this form and this form. Finally a bracket and 2-. Hopefully you enjoy that.